This video showcases some examples in finding indefinite integrals using the basic theorems. Welcome to Integral Calculus. The first example is to integrate 3x raised to 5 times dx. Extract the constant from the integrand and proceed to the simple power formula, which integrates x raised to 5 into x raised to 5 plus 1 over 5 plus 1. Then add the arbitrary constant c. Simplify the term and have 3 times x raised to 6 over 6 plus c. Reduce 3 and 6 to have x raised to 6 over 2 plus c. This is the simplified integral of the function. The second example involves the terms 15x raised to 4, 6x squared, and 2. With three terms connected by a plus and minus, distribute the integral to easily solve for the antiderivative. At this point, it is easier to use the simple power formula. So the first term becomes 15 times x raised to 4 plus 1 over 4 plus 1. The second term follows with a minus sign, and its antiderivative is 6 times x raised to 2 plus 1 over 2 plus 1. Then proceed to the third term by adding the integral of 2 dx, which is 2x. Then don't forget to attach c. Simplify the procedure to get 15 by x raised to 5 over 5 minus 6 times x cubed over 3 plus 2x plus c. Reduce 15 and 5 and also 6 and 3, coming up with the final antiderivative as 3x raised to 5 minus 2x cubed plus 2x plus c. How about if the function to be integrated is 6dz over z raised to 4? First is to simplify the function by eliminating the denominator, and that is through flipping the denominator up to the numerator by using reciprocals. So the function becomes 6z raised to negative 4 dz. Now place the constant outside the integrand and get 6 with the integral of z raised to negative 4 times dz. After the adjustments, we can proceed with the simple power formula, which turns out as 6 times z raised to negative 4 plus 1 over negative 4 plus 1. Then again add the arbitrary constant. Simplify the term to have 6z raised to negative 3 over negative 3 plus c. Then reduce 6 and 3 to give negative 2z raised to negative 3 plus c. So the antiderivative of the function is negative 2 over z cubed plus c. Example 4 involves the integral of the root of t less the reciprocal of the root of t times dt. Radicals can be transformed into rational exponents to easily add 1 later. So the function becomes t raised to 1/2 less 1 over t raised to 1/2. The next thing to adjust to keep a one-line function is to eliminate the denominator. So flip it up using its reciprocal, thereby making the solution the integral of t raised to 1/2 minus t raised to negative 1/2 times dt. Having simplified the function, distribute the integrand among the terms, t raised to 1/2 and t raised to negative 1/2. Then use the simple power formula. That would give t raised to 1/2 plus 1 over 1/2 plus 1 minus t raised to negative 1/2 plus 1 over negative 1/2 plus 1. Then add c. Combine coefficients and exponents to have t raised to 3/2 over 3/2 minus t raised to 1/2 over 1/2 plus c. Then finally, flip the denominators to have the integral of the function as 2/3 of t raised to 3/2 minus twice of t raised to 1/2 plus c. The next example has rational exponents readily, so we start with flipping the denominator to the top, making the function the antiderivative of u raised to 3/2 plus u raised to negative 3/2 times du. Having a simple function, distribute the integrand among the terms, making two integrands, with u raised to 3/2 du and u raised to negative 3/2 du. Now proceed with the simple power formula and get u raised to 3/2 plus 1 over 3/2 plus 1, plus the other term, u raised to negative 3/2 plus 1 over negative 3/2 plus 1. Then add c. Combine the constants and the exponents to get u raised to 5/2 over 5/2 plus u raised to negative 1/2 over negative 1/2 plus c. Simplify the denominators by flipping them and get 2/5 of u raised to 5/2 plus 2u raised to negative 1/2 over negative 1 plus c. Lastly, move the negative exponent to the denominator, giving 2u raised to 5/2 over 5 minus 2 over u raised to 1/2 plus c.